Alright everybody, in this video I'm going to solve few numericals related to the principle of moments. But before that let me show you with the help of this simulation what is the meaning of principle of moments. Although in the previous video I have explained it, kindly do check that. Okay, here as you can see there is a beam balance. Yeah, right now it's in balance condition because clockwise moment is equal to anti-clockwise moment. Um, what is the meaning of moment here actually? Moment of force or torque is the force required for rotational motion. Right now, no torque or no moment is acting on the rod. Now, check this one. Let me show you what is the meaning of clockwise moment. Clockwise moment means the moment which will rotate the body in clockwise direction. Check this one. If I suspend this or if I put this 5 kg mass on this side, the rod will tilt clockwise. This is clockwise moment. If I put rod on this side, the rod will tilt anti-clockwise direction. So this is anti-clockwise moment. Now if I want to balance that anti-clockwise moment, clockwise moment should be equal. Now let me keep 5 kg mass 5 kg mass on 8 centimeter. Now it is in balance condition. It means clockwise moment is equal to anti-clockwise moment. So this is the principle of moments. Now based on this I'm going to solve few numericals. So let's begin. Yeah, so let's begin with this numerical. This numerical was asked in 2018 ICSC. You can check it, 2018 ICSC board exam. Alright, so let's check. Let's solve this numerical. As it is mentioned here, a half meter rod. Half meter means 50 centimeter, right? This is 0 centimeter mark and up to here 50 centimeters. So you need to be careful. This is related to half meter rod pivoted at the center. This is the fulcrum. Two weights 20 GF and 12 GF suspended at a particular distance 6 centimeter and 10 centimeter from the pivoted respectively as shown below. Okay, 20 GF at a distance of 6 centimeter from the fulcrum and 12 GF 12 gram force at a distance of 10 centimeter from the fulcrum. So check this one. We need to calculate which of the two forces acting on a rigid rod causes clockwise movement. So obviously very simple basic questions they ask in exam. So as you can see 12 GF 12 gram force will rotate the rod in clockwise moment, clockwise sense. So this will produce clockwise moment. So all you need to write is 12 gram force will produce clockwise moment. Simple. Alright, further. And 20 gram force will rotate the rod in anti-clockwise direction. So that is not asked in this question, but yeah, still. Okay, further. Is the rod in equilibrium? So for that purpose we need to check whether clockwise moment is equal to anti-clockwise moment or not. So let's calculate the clockwise moment and anti-clockwise moment. But what is the formula? Oh dear Lord. So first of all let's check the formula. Alright, no problem. So let me call it F1, let me call it F2, R1 distance of the F1 from the fulcrum, let me call it R2 distance of the F2 from the fulcrum. So clockwise moment, this is clockwise moment, F1 into R1. Anti-clockwise moment, this is anti-clockwise moment, F2 into R2. If they both are equal, then we say rod is balanced, and that is the principle of moment. So let's use this formula to solve that numerical. Alright, so let's verify. Second part. Anti-clockwise moment. This is anti-clockwise moment. Let me call it F1. and its distance from the fulcrum is r1 is equal to clockwise moment. Oh dear lord, just a second. Yeah, r2. Well, alright, what is f1 here? Let me call it f1, 20 gf multiply by its distance, that is 6 centimeter. On this side, f2, that is 12 gf multiply by its distance, 10 centimeter. And if you multiply these two number, 120 gram 4 centimeter, and on this side again we will get 120 gram force into centimeter. So it means moment on both the sides are equal. We can say that clockwise moment is equal to anti-clockwise moment. So the rod is in equilibrium, means it is in balance condition. So simple numerical they ask in exam. Okay, these type of numericals you need to practice. Well, such numericals are not there in the textbook, but yeah, concept based similar type of numericals are there, so you need to solve them as well. Now let's moving on to the third one. The direction of 20 kgf, it's gf actually, not kgf, let me rectify it. Yeah, direction of 20 gram force is reversed. What will be the magnitude of resultant moment of force on the rod? Well, right now it is in balance condition, it's not rotating, but if I reverse the direction of this force here, so let me show you that. Let me just erase this part here. So let me redraw the diagram here. Oh dear lord. Yeah, oops, sorry. Wait a second, something is wrong here. Yeah, now it's working. Okay, so I need to reverse the direction, means here let me reverse the direction of 20 gf. Fulcrum is at the center, 12 gf is already pointing downwards. Now its distance here is 6 centimeter, here the distance is 10 centimeter. Obviously now this rod will rotate in a clockwise sense. Now this is not in equilibrium, so we need to calculate the resultant moment. Earlier the resultant moment was 0, it was in balance condition. Now it is not in balance condition because it will rotate now. So let's calculate the total moment. So we have already calculated this moment. Moment on this side, it was, let me call it f1 r2, that will be 120 gram 4 centimeter. I have already calculated that. Now moment on this side, I called it f1 r1, that will be again 120 gram 4 centimeter. Now these two moments will add up, so total moment of force, total moment of force, 120 plus 120, this will cause rotation in the rod, 240 gram force centimeter. And well, you need to write further that this will be clockwise moment, because as you can see the rod will rotate in a clockwise sense, means like this. Okay, clockwise direction. So you need to write that in the bracket down below. And you know what such type of numerical they ask in exam. So simple hai, ज़्यादा कुछ नहीं है. All you need to use the formula, do some calculation, and you will get the answer easily. Now let's move on to the next type of numerical. I'll call it type 2 because in that we have to calculate the weight of the rod. Okay, so let's move on to the next one. Yeah, check this one. I'll call it type 2 because here we need to calculate the weight of the rod. So let me draw a rod here. Oops, yeah. Okay, check this one. Half meter rule. Again, this is related to half meter rule. This numerical was asked in 2018, I think. Yeah, in 2018 ICSE, you can check it. Okay, half meter rule balances horizontally on a knife edge at 29 centimeter mark. So fulcrum is at 29 centimeter mark. So here the beginning with 0. This is half meter rule, so 50 centimeter. And the knife edge is at, I mean the fulcrum is at 29 centimeter. That's it. Now, well. Okay, further. When the weight of the rule 20 gf, sorry, when the weight of 20 gf is suspended from one end. Now there are two ends, 0 centimeter mark and 50 centimeter mark. Now the question is, where should I suspend 20 gf, and why should I suspend it actually? Well, check this one. The center of gravity of the rod is always at the center, where it will become balance. Area. It's too hard to balance this pen right now. Yeah, check this one. Okay, now here the fulcrum is not at the center. The fulcrum is at 29 centimeter mark. Okay, the weight of the rod is always situated at the center. If you keep the fulcrum at the center, it will become balance. So first of all, you need to show the weight of the rod, and that is always at the center. So let me show you the weight of the rod always at the center. Center means this is 50 centimeters, so its weight will be at 25 centimeters. So let me show you 25 centimeter here. At this position, weight of the rod will be situated. We need to calculate the weight of the rod. So obviously it will tilt on this side now, because the fulcrum is not at the center. It is somewhere here. So it will tilt this side, because this side is heavier now because of weight of the rod. Now if I want to balance it, I need to suspend 20 gf on another side here at this end. So the rod will become balanced now. So first of all, you need to complete the diagram, and then you can use the principle of moment to calculate the weight of the rod. Check this one. This will be R1, and this distance will be R2. So let me call it F2, and this will be F1, I mean weight of the rod. So principle of moment, clockwise moment, that is F2 into R2. I'm directly writing anti-clockwise moment, that is F1 into R1. So you need to write here according to the principle of moments, clockwise moment is equal to anti-clockwise moment. This is clockwise moment and this is anti-clockwise moment. So let's put the value 20, and its distance, well, what is the distance here? 50 minus 29. 50 minus 29, how much that is going to be? That will be 21, right? 21. Okay, well, F1, I mean weight of the rod, we do not know. We need to calculate that. Its distance from the fulcrum. Always measure the distance from the fulcrum. So 29 minus 25, that will be 4 centimeter, isn't it? Yeah, 4 centimeter. Okay, now let's calculate it further. Let me solve it further. Let me change the ink here. Yeah, so this will be 5 times and 21. So how much this is going to be now? 5 1 ja 5, 5 2 ja 10 gram force. Alright, 20 gf, sorry, 105 gf is the weight of the rod. First of all, you need to calculate, first of all you need to complete the diagram, and then with the help of principle of moments, you can calculate the weight of the rod. So do practice such type of numerical. Let's solve one more such type of numerical where we have to calculate the weight of the rod. Let me show you that. Yeah, check this one. Again, okay, they have completed the diagram, no problem. But you know what? This is 1 meter rule. A uniform meter rule means 0 to 100 centimeter. Weight is always at the center. So let me show you center somewhere here. I mean at 50 centimeter. That will be the center of the rod. And the weight will be situated here, center of gravity. Okay. Here the fulcrum is at 30 centimeter. It means it is in balance condition. Okay, so we need to calculate the weight of the rod. Let me call it R1, and this distance, let me call it R2. Okay, now calculate the weight of the meter scale. So first of all, you need to complete the diagram. You need to show the position of weight of the rod that will be always at the center. Here this 100 centimeter 1 meter rule, so weight will be at the center at 50 centimeter mark. Chalo, clockwise moment W into R1, anti-clockwise moment, let me call it F1, sorry F2, and let me call it F1, that is W only. Okay, F2 R2. So this is clockwise moment, this is anti-clockwise moment. So we need to calculate the value of W. Its distance from the fulcrum, 50 minus 30, that is 20 centimeter. F2 they have already given 40 gram force, and its distance from the fulcrum, 30 minus 5, that will be 25. Okay, this will be okay. Now let's solve it further. 1 0 1 0 will get cancelled. Let me change the ink here. Okay, 1 0 1 0 got cancelled. This will be 100 and W into 2. Oh dear lord, yeah. So W will be 50 GF, isn't it? So first of all, you need to complete the diagram, and then with the help of principle of moments, you can calculate the weight of the rod. Further, the second part, which of the following option is correct to keep the rule in equilibrium when 40 gram force is shifted to 0 centimeter mark? Okay, so let me draw the diagram for this part. So in this part, in second part, they have asked which of the following option is correct to keep the ruler in equilibrium when 40 gram force, I mean this weight here, I'm going to suspend it here, 40 GF. So obviously this moment will increase now. Alright, so to decrease the moment, to make it balance once again, I need to shift the fulcrum towards 0 centimeter. So here, first option is correct here. You don't have to solve anything here, you just need to write that. You don't have to draw the diagram. Okay, you just need to write that F is shifted towards 0 centimeter mark, because if you shift 40 GF here at 0 centimeter mark, this moment will increase. So to decrease the moment, you need to decrease the moment arm. So you need to shift it somewhere here, say somewhere here. If I shift it, it will become balanced once again. So you don't have to draw the diagram. Okay, you can draw the rough diagram, and you can say that F is shifted towards 0 centimeter mark. First option is correct here. Okay, so such type of numerical they ask in exam. Do practice. Thank you very much.